If you take one picture away from this whole course, make it this one. People say the database, like it's a single thing. It isn't. Oracle is really two things working together, an instance and a database, and the fastest way to sound like you actually know Oracle is to keep those two words straight. So before we touch a single command, let's draw the picture that every other topic hangs off of. Here's the mental model. The database is the data at rest, a set of files sitting quietly on disk. The instance is the data in motion, the software that's actually running in memory, made of a shared memory area and a handful of helper programs. When the instance starts up and connects to those files, the whole thing is open for business. When you shut it down, the files don't go anywhere. They're still on disk, but they're useless until an instance comes along and mounts them again. Data at rest, data in motion. Learn each half, then connect them. Quick roadmap so you know where we're going. First, we'll split Oracle into its two halves, the instance side, which is memory and processes, and the database side, which is the files on disk. Then we'll follow a single query from a user, all the way down to disk and back. We'll talk about why Oracle leans on memory so hard, how it guarantees you never lose a committed change, and we'll finish with a single clean sentence you can say in an interview that ties the whole picture together. 6 beats. Let's go. Let's open up the instance. It's made of 2 parts, and each one gets its own chapter later. The first is a big chunk of shared memory called the System Global Area, almost always just called the SGA. Its whole job is to cache things, copies of data blocks, parsed SQL, dictionary information, so Oracle doesn't have to keep running back to disk for the same stuff. The second part is the background processes. Think of them as the building's maintenance crew. Small programs that never stop running, quietly writing change data out to disk and recording every change so the database can recover after a crash. Instance equals shared memory plus a crew of helpers. That's it. Now the database side, the files on disk. There are 3 types that matter most, and a strong candidate can state the job of each in one sentence. Data files are where your tables and indexes physically live. They're the big ones, and they grow as your data grows. Control files are small but critical. They're the table of contents, recording the structure of the database and where it is in recovery. And the online redo log files record every single change as it happens, in order so that if the instance crashes, Oracle can replay them and get back to a consistent state. Data holds the data, control holds the map, redo holds the history. Let's put them side by side, because the contrast is the whole point. The instance is software running in memory. It only exists while it's started. It's made of the SGA plus background processes, and it's your data in motion. The database is files on disk. It exists whether or not anything is open. It's made of data files, control files, and redo logs, and it's your data at rest. And here's a classic follow-up an interviewer will spring on you. Can the database exist without an instance? Yes. It's just files. It only becomes usable when an instance starts up and mounts it. Nailing that distinction is what separates someone who's read about Oracle from someone who's run it. The best way to lock this in is to follow one query from start to finish. A user's application connects over the network and hits the listener. That's the front door, and we cover it in Chapter 13. The listener hands the connection off to a server process inside the instance. That server process needs some data blocks, so the first thing it does is check the SGA. If the blocks are already cached there, great, it reads them straight from memory, which is fast. If they're not, it reads them off disk into the SGA first, then serves them. And when the user changes something, that change gets recorded in the redo log so it's never lost, and the modified block gets written back to the data files later by a background process. That flow, client, listener, server process, memory, disk, is what lets you confidently answer any what happens when question. Why does Oracle cache so aggressively? Because RAM is thousands of times faster than disk. When a server process needs a block, the good case is a cache hit. The block is already in the buffer cache inside the SGA, so it's read straight from memory. The slow case is a cache miss. The block isn't there yet, so Oracle has to go out to the data files, pull it into the SGA, and then serve it. That's the whole reason memory sizing matters, and it's the thread that runs through performance tuning later in the course. Keep the data your users actually need sitting in memory, and everything feels fast. Now, how does Oracle promise it will never lose your committed work? The redo log. Every change is written into the redo log the instant you commit, in order, so even if the instance dies a second later, that change is safely on disk and can be replayed. Meanwhile, the control files keep the recovery map, the structure of the database, and how far back recovery would need to reach. They're small, but they're so important that you always keep multiple copies. Put it together. The SGA stays in sync with the data files, thanks to background processes. Every change is protected by redo, and the whole layout is described by the control files. That's the safety net holding the entire system up. Here's the payoff slide. If you can deliver this one sentence smoothly, you've basically answered the opening architecture question before they finish asking it. Listen, a client connects through the listener to a server process. That server process works against the shared memory of the SGA. The SGA is kept in sync with the data files on disk by background processes, and every change is protected by the redo logs and described by the control files. Say it a few times out loud until it flows. Once that sentence feels natural, everything else in this course is just filling in the detail. Let's prove the whole model with two commands you'll run constantly. Query $instance, and it tells you about the instance, its name and its status. Here it's open. Query $database, and it tells you about the database itself, its name, and whether it's open read-write. Notice how neatly that mirrors what we've been saying. $instance is the running software, the data in motion. $database is the files on disk, the data at rest. Two halves of Oracle, two views. We'll live in these dynamic performance views all course long. That's chapter 17. Let's lock it in. Oracle is an instance plus a database. The instance is the SGA and the background processes. The database is data files, control files, and redo logs. Requests flow from the client through the listener to a server process, which works against the SGA and reaches disk only when it has to. Memory first, always. A cache hit beats a disk read. And the trap to remember, the database can exist with no instance running, because it's just files at rest. Next chapter, we take this single database picture and blow it open, because in modern Oracle, one instance can hold many databases at once. That's multi-tenant, CDBs and PDBs. See you there.